All right, so now we're going to go into the second way to find the number of half-life cycles. So just to remind you, in all cases, in all these half-life problems, you always want to start by finding the number of half-life cycles. And we looked at how you can do that using a table that either you created, like I created here, just by starting with your initial amount and dividing it by half until you get to the final amount. And the number of times you divide by half, or not divide by half, divide by 2, the number of times you have it, or divide by 2, is your number of half-life cycles. Now we're going to go into the second way you can find your half-life cycle, which is using one of the equations. So there are two equations here. You notice that both equations have the half-life cycle. So the first one, it's here, number of half-life cycles equal to elapsed time over half-life. And for the second equation, it's the final amount equal to initial amount divided by 2 raised to the power of the number of half-life cycles, okay? So when you're using the equation, the first thing you need to figure out is which equation you're going to use, because both of them have half-life cycles in them. So in the first equation, notice that you have two other variables besides half-life cycles. You have elapsed time and half-life. So that means if you're given in that problem the amount of time that has elapsed and the half-life of the radioactive isotope, you're going to use equation 1. If, on the other hand, your problem gives you the final and the initial amounts, you're going to use equation 2. Now, in using equation 1, this is essentially what I like to call plug and chug, where you plug in the values that you do have, which will be your elapsed time and your half-life. You just plug them in and solve for your half-life cycle. Okay? This doesn't require logs. In the case where you are having to use equation number 2, you will need to use log base 2 to solve, because notice your half-life cycle, if that's your unknown, that is in the exponent. And in order to remove it from the exponent using inverse operations, you're going to have to use log base 2. So that's something that's important to keep in the back of your mind. Now, once you have solve for your half-life cycles using either the table or these equations, then you can go ahead and solve for what you're trying to find, whatever it is that you're asked to find in the problem, using the other equations. So that means, for example, if I use equation 1 to find my half-life cycle, then I'm going to probably have to use equation 2 to find my unknown, what the problem is asking me to find. On the other hand, if I used equation 2 to solve for my half-life cycle, then I'm probably have to use equation 1 to solve for my unknown. So that's typically how these problems work. Okay, so what I want to show you is sort of the two examples, sort of go through those two examples with you so that you kind of understand it, but you also have this scanned into Schoology.